Okay, so today we're going to use the RCWT calculator to make a binary amplitude grating from a chromium grating. And to start RCWT, you go under Accessories with the RCWT calculator, and we're going to choose a wavelength of 650 nanometers, so I set that. And the theta, phi, and psi are angle parameters for the input. Here's a picture out of the manual where the theta is the angle from the z-axis that's coming down from the top, incident angle, and phi is the angle from the x-axis, and psi is the polarization, where 0 p and 90 degrees is s. So we're going to set this up for right now it's p polarization, and we're going to choose plus or minus 1 diffracted orders. You can do more orders, it's just it gets a little confusing on the graphs. We'll start at a 0 degree angle of incidence for theta and stop at 50 degrees with an increment of a half degree. And then we're going to look at reflected and transmitted diffraction efficiency. Now we've set up the basic calculation. We have to go and set up the grating. So I'm going to choose 30 orders here with a base period of 2 microns, so that's the pitch. And you don't have to worry about number of periods here. That should just be set equal to 1 for this basic calculation. And the index of the incident medium, I believe that's spued silica, 1.4608, and we're going to do the substrate at a refractive index of 1. And I'll show what those values are and how they relate to the geometry in just a minute. Then we're going to go into RCWT layers, and yours may or may not look like this, but what we want is 1 layer of chromium. So we're going to specify the height of the chromium at 100 nanometers here, and that'll be for this layer. We only need 1 layer, so we don't need anything else there. So that's the 100 nanometers, and then the duty cycle, I'll explain that more when we get into the blaze grating, but the way it's set up right now is for a 50% duty cycle. And then index 1 is the first material, index 2, that would just be the air that we're going into, and index 2 is the chromium. So if we do a preview here, you'll see here's on this picture the light is incident from above, so the incident medium is the spued silica, and then here's the chromium, and then the substrate is air down here. That's got a blue color one. And then medium 1 is the air, and medium 2 is chromium. So now all that's set up okay. So we can go back to this window and just calculate diffraction efficiency. And you wait a minute, and the results come up. Okay, so here's the transmitted diffraction efficiency and the reflected diffraction efficiency versus angle in degrees for theta. That's what we chose. And if you want to do S polarization, you change that to 90, and you can calculate again. And there's the transmitted and reflected diffraction efficiency for S polarization. And this is in a fraction, not percent. That's it.